Okay, let's get to this the value of pixel thingy. Thank you for coming, first of all. Okay, who am I? Angelo. Hi. Currently the director of rendering engineer at Roblox. I worked in the past for many companies, did many games, EA, Activision, and a bunch of others. Yeah, and sometimes I write things, which is, I guess, why I was chosen to do this. So why this meetup? Well, personally, it's for very selfish reasons. It's very lonely. This is me talking with my girlfriend and the trace route going up to Vancouver. So I've been in Vancouver for 10 years and I'm totally new to the valley. So I wanted to connect with the community. Luckily, I go to some conference and stuff, so I knew some people. I was like, oh, let's get them all in the same room. Let's try to organize something. And actually, so I used to do this. I had like a rendering related group in Vancouver that I did 3-4 times, to be honest. Like it ended up being a lot of work just to contact all the people and poke them. And it's like, are you coming? So anyway. Yeah, and that's, if you recognize that game, that's Mass Effect. That actually had the futuristic / dystopian Vancouver as one of the environments. So, okay, this time I thought, well, I will be smart and I won't organize it. I will ask for help and have Roblox do it. Which on one hand, it worked very well because people were really like, yeah, we should do this. Let's like grab the people, get in the room. Okay. The bad part was that then when we were closer to the, like doing some meetings to organize this thing, they were like, okay, so what shall we do? And like everybody looks at me, it's like, no, you're good. Like you present stuff, right? It's like, yeah, sure. So now I have to present something. So all my attempts as laziness kind of backfire and I end up needing to do more work. Luckily, I don't know, like I have lots of notes and ideas and half-baked things, so I was like, yeah, I probably can say some stuff. Specifically, I had this presentation that it was almost done. Like, look at all the slides. And it was called like, what that's temporary title. Open problems in real-time rendering in video games. That sounded something very relevant. So it's like, okay, sure, I can do that. And well, kind of problem solved. And I think we have a lot of those, right? Even in very fundamental, basic things that we have been doing for decades. For example, like a lot of people think about, oh, dynamic GI, and that's an open problem. But to me, like even good old boring baked static GI is very complicated. Like we have those light maps, we have those voxels, and they all break in weird ways in different situations. It's totally an open R&D field, in my opinion. And I guess also in others. Those are a couple of papers from i3D, and I was just there last week, that kind of tackles some parts of it. The Maguire one is very, very interesting, but also this like probe placement is actually a very cool one. And there are lots of other things, like what it means to be physically based. Everybody is on PBR, but I think that even there is like so much that we have to find out. And if I'm really in a silly mood, I could even say a couple of things about, I don't know, ray tracing or VR or streaming or all those things that everybody is talking about and everybody's very excited to do. But okay, so that's the thing though. Like I looked at all the slides sometimes, and I feel like people already know about a lot of those stuff. And like, for example, with ray tracing, everybody's already talking about that. So I don't know, I have this internal function of what I want to talk about, and I know how tuned it is to what people will find interesting, but it's just mostly like what I'm thinking in that period of time. So I kind of felt, nah, this is, I don't know, I don't think this is cool enough. I want to talk about something a little bit different. So that's literally picture that I kind of snapped on the plane as I was putting some notes down to write these slides. I was like, okay, I'll do an incredibly like totally new slide deck. So all this introduction to say, this could be very good or completely terrible. I haven't rehearsed. I like finished the slide yesterday. We'll see how it goes. Okay, so what do I mean with the value of pixels? Okay, so not literally the monetary value, right? I don't know if you're old enough to remember that infamous $1 million homepage. There, like pixels actually had a very well-defined value, right? It's more like, okay, what is the value of our work of rendering engineering, rendering research? What should we spend our time? And I really like this book. And here there is this chapter about the hungry beasts, kind of describing the pressure of production and how successful products always want more feature and more things, right? So, and sometimes I misquote in the book, actually, I called it the production monster, like all this set of pressure. So when you're working in games in AAA and stuff like that, and you're in production, things tend to be kind of simple in a way that you typically have a gigantic list of things that people want from all direction, from gameplay to art. And you don't really have that much time to strategize, right? It quickly becomes a panic mode of making that list into priorities and then start working on the top like risks and then end up cutting a lot of things for the next time, for the next game, right? So it seems to me every time I was in production teams, kind of the work was very, very hard, right? But there was never time even to like really think about, oh, what am I doing? What I should do like more in the long-term horizon. When you get out of production, and in my experience, you start to work maybe on a central team, on an R&D team, or, well, now at Roblox, I'm not doing games, right? So you start asking yourself a little bit more, like, okay, should I spend, there is this R&D project, should I spend 3 months and do it to a given degree, or should I spend 6 months, should I spend a year and do it really, really good, right? If you don't have that pressure of, oh, the game has to ship tomorrow, there is a lot of questions that you ask yourself. And yeah, so I started thinking about what should we do, right? Why are we investing in certain things versus certain others? And what is the impact and value of rendering? And these are a few current generation games that I like, rendering-wise. It's just a random sampling, right? There would be too many to mention. Probably you recognize all of those. I don't know, are they best-selling? Are there games that people would agree have the best graphics? If you ask to our clients, some definitely are, some maybe are less. One thing that I notice is that a lot of times the public actually loves the end visuals of products that I don't think have that much technical innovation behind them. And so that kind of makes you in an existential crisis of like, why am I doing this then? Anyway. And okay, also I want to be clear because sometimes people come up to me and it's like, oh yeah, Angelo is like, he thinks that rendering is dead and useless and everything. Right? It's very contrarian those days. And so I want to be clear that as a premise, I don't think that rendering is dead, not that it has peaked or other things are more interesting. It's kind of a pet peeve, like when people say, oh, rendering has peaked. I'm like, no, it's just a lack of imagination. And the example that I bring to like kind of explain myself is like, look at your screen and look out of the window. Is it the same? No, so you still have work to do, right? We are not rendering things as they are outside of that window. And would it be very, very cool if I could play games with that kind of perception of realism? And I think so. I think that it would be much more emotional, it would be much more immersive. So I think that there is still a gigantic amount of work to do. And there is also value in doing that work. Like, it would be really a cool thing to have, to not be able to distinguish reality from our simulations. But I also think that you're not going to be Carmack anymore. And it's not your fault, nor anybody's. I don't think that Carmack is going to be Carmack anymore, even if I guess Oculus is on his part a fair try. But what I mean is that it's extremely unlikely that our lines of codes are going to create an entire video game genre. Arguably, he made one of the most popular today, right? So back in those times, there was an immediate connection. You create a new rendering technique, being able to do something that wasn't done before, and you made a product, like not only a product, even an entire genre, like such a powerful thing. I don't believe that no matter how smart your code is, and even if today, arguably we are solving much, much harder problems, right? Our solutions are going to have this kind of impact in the industry. So we moved on, and for a while, I think that we had rendering at this kind of back-of-the-box feature, right, so to speak, right? A game-defining feature. So that's an example. I think it's Call of Duty Modern Warfare 2, and at the time, it was one of the very few FPSs that run at 60 on the consoles, and because it's a competitive shooter, that like fluidity was arguably a game-defining feature, right? So now everybody can make FPSs, but still your code can be a big differentiator of like why your product has this, like, is different from others in the competition. And today, I don't think that things are as clear, right? So you can grab an off-the-shelf engine and create like truly incredible graphical things with it. Most games won't have problems running at 60. The games that ship at 30 today are mostly because of explicit choices. Arguably, content makes more difference than most rendering technology. And then again, not because our job is solved or is any easier, but the direct impact on the product, I feel, is not definitely as big as those years. So this is like also like one thing that really keeps me up at night. And okay, this PT like literally does. I don't know if you managed to play it. Like I'm incredibly scared by horror things, but I think that's the fun. So I really, really like this game. No, but I mean like more figuratively, what keeps me up at night is going to SIGGRAPH every year and doing those madmen doing movie production and visual effects. And just the amount of work and the amount of data that goes for a few like seconds, you know? A single scene is incredible. This is from Blade Runner, the latest Blade Runner, right? And if you've seen the kind of behind the scenes, it's also a little bit funny in a way. Like, I mean, I'm sure that it's necessary, but they create this entire city, and then there is so much levels of fog that you can't see a lot of this geometry, but it's still there. And well, you do fly-throughs and stuff like that, right? And literally, I love to go to SIGGRAPH to see the production talks from the TVs and movie companies and see like how much things they move and how like they do in a week generate such incredible amount of content, right? And when I look at that, why I say it's scary, because I think one day all this will be ours, right? And this has been the trend, and I don't think it will stop, right? Like the video game rendering, the real-time rendering kind of lags a little bit, some years behind the movie industry, but there is no reason to think that we won't reach the same thing. So you can go to SIGGRAPH and look at those talks and imagine, oh, how do I render all this thing? Or how do I produce all this thing, right? That is very scary to me. And you also, of course, all very well know that it's not only that, like movie have them, the problem is in a way simpler, because you just create a scene, you don't have players, right? You don't have this interactivity and things. that want to look at your scene from all the different angles. You can create a scene with any software that you like, right? You could even go and rotoscope or paint out the things that you don't like. Well, for us, any technology that we make is the technology that has to ship the game. We can't like do, oh, for this scene, use Lightwave, and for this other scene, use this experimental Maya renderer that I did that works only in this situation, right? Okay. And a lot of this is not news, and a lot of like, it has been going on for a while. That if you talk to people, they would be concerned about how expensive and how big our production is becoming in the video game industry. So costs like can't keep increasing. This is very good talk by Ralph Koster. It's very insightful. But to be honest, we've been saying this for quite some time, and yet I don't really see a lot of change in the way that we do our products. I don't see that suddenly we are shifting from having like 10 people on the rendering team to having 10 UX experts or tool experts. So there is a little bit, like we do care about our tools, but in my experience in few companies I've sampled over the years, it hasn't been like, oh, okay, let's stop progressing on the complexity on the rendering side of things, on the feature side, and start like really looking at what we can do in terms of R&D, in terms of workflows and stuff like that. And I don't know, like, I wouldn't imagine that our industry is dumb. I never assume that our top professionals are. I'm guessing that it's kind of still that production monster kind of idea. You're running a very successful product, and yes, you could spend some engineering time to shave a minute here and a minute there, but on the other hand, you have that huge list of askings from like your game designer and art directors, and you still prioritize that because you know that, okay, we can like take a little bit of pain, but deliver a little bit more features, and that will sell us more copies, and we're still growing, so it's okay to take that compromise. Today, though, things may be shifting, and then again, I'm not entirely sure about that, but I'd say they may be shifting, because I start seeing like this as a problem, right? Now, I guess everybody knows if the AAA games, you're not done when your game is done, right? When your game is done, it's just the start, and there is like this long tail of support and producing content. And a lot of games are made or broken based on that, right? So you can have a very successful launch, and then you don't manage to keep that game fed, right? You don't manage to push updates and downloadables and just new content to keep your player base engaged. And you start looking at a lot of articles saying, oh, well, it went well, but after a month, there are no players anymore, right? It's a very common kind of thing. So with this new model, we may be rethinking our agility on the side of what we do with content production and things like that. And I don't think that this is really like unique to rendering or very surprising. I think this is a kind of natural path of most technology. You start at the beginning where things are not possible, and so someone finds a way to make them possible, and technology becomes the product itself. And then things are starting to be a little bit more obvious. Everybody can do it, but smart tech is kind of a product-defining features. Right? And then you move to, well, now this is a very well-established field. So we have to like think of technology as how it enables people, how it enables production, not just as I'm making a very fast renderer and thus my game will sell, right? So I think that currently we are there. And I mean, all this shift, I want to be clear, doesn't mean that technology becomes simpler, right? Our problems are harder. And they're still all technical. It's just that we have to like understand what is the value of the technical problems that we're solving in this kind of context. So we can't evaluate value in isolation on some technical merits alone. It's all about the iteration with our clients. if you do rendering, or your artist first, and then the people buying the game. And not only our technical problems are arguably harder, like even from a purely R&D perspective, your code bases are gigantic, things are much, much harder. But understanding people is a completely other level of complexity. Right? People are much less predictable than GPUs and things you can cycle count and things like that. Okay, so what does this mean, thinking about people, and where do we go from here? Well, one avenue is procedural generation. There is this deep learning thing. Okay, you can see that my heart is not in it. So no, this is not what I'm talking about. So, and mind you, okay, those things can be terrific tools. There is no denying that they're very, very interesting things to think about. But if I say, oh, well, yeah, sure, content is a problem, so ProcGen, right, is the solution. It's kind of putting technology first again, like thinking that, okay, you can write some code and you're solving things. And I chose these two examples exactly because actually they are often cases where that explicitly happens, right? They're cool technical ideas, but they are very dangerous in a way that a lot of times they don't consider the people that have to use those tools. So those are great examples of actually technologies that have a big challenge of, okay, how do I do ProcGen that is still controllable, that an art director will be happy with? How I do like generative models, machine learning in the way that next time that someone adds to that set, it doesn't completely change the result and everybody's on fire, right? So those are examples of, yeah, there are very good ideas, but if we don't think about the people, we're not really getting anywhere. So what are we going to do? I don't know. That's why it's called open problems. If I knew, it would be closed problems, and I would make a startup or something. But I can start by asking some question and to kind of reconsider our assumption. So I organized this kind of as a series of thought experiments and design axes and things. So originally I wanted to leave this part for last, but then I figured, okay, let's start with the hardest thing. And let's go back about talking about cost and production and like just trivial like money kind of matters. And you may have recognized this guy, Jackie Chan. And it's interesting, like in one of the interviews that I've seen of him, he was saying that his style of shooting action movies wouldn't really work in Hollywood because the kind of stunts and the kind of choreography that he does requires so many takes, like tens of hundreds, that if you have a set, you know, a huge expensive production with so many people around you, you can't afford doing that. You can't afford that iteration. And so he explicitly works in a much simpler way, like with being as cheap as possible in a way, because his style of movie requires that, right? Requires the ability of shooting for days on end without worrying of going over budget. So that was very, very inspiring. And it makes you think, like, okay, what if we wanted to deliver AAA, like state-of-the-art games on like a tenth of the budget, right? And this doesn't matter. I can say like half, or I can say 10% less. Really, the percentage is really not interesting. What I find interesting is how we would achieve that. If you had that constraint, what would be the ideas that would enable you to do like a much, much faster kind of iteration and production? And it's also interesting because then again, with this analogy with Jackie Chan, like it's like if we had those, I don't know, 1/10 cheaper tools, would the end result end up looking even better just on the virtue of being able to be much more nimble and experiment and throw away a lot of ideas and iterate on things instead of having to do like one very, very, very high quality rock that you can do just once because it takes like 2 months to finish. And this, again, is a theme for Creativity Inc., so it's not too much of my own mind. So in the book, it's described this company-wide meeting at Pixar they called Notes Day. And the topic of this first company-wide meeting was about how would we cut costs by 10%. And it's like there are a couple of phrases that this is about making 3 films every 2 years with roughly the same number of people we got today. It's also very interesting to read that part about Guido Quaroni, the VP of the tools department, and his idea of keeping the tools engineers engaged. And okay, as we think these thoughts, I think we also have to talk about the trade-offs of high-quality graphics. And I don't think that we do this often. Right? We kind of assume that pushing rendering fidelity is the mission of rendering, and that has an implicit value. And now, I don't believe this is a universal truth. Right? I don't think that the mission of rendering is necessarily going all the way to, in all cases, to high fidelity. I do think that photorealism is a very powerful tool. I can see why that's the case. It's a very common language, so it's very easy to like tell stories or make gameplays in like a cinematic universe or in things like that we know that we have a very solid anchoring to. But in the end, rendering graphics are kind of are communication tools. Right? We are visual animals, and we really don't talk about this kind of design spectrum. Like when it's appropriate to sacrifice some fidelity for iteration times, or would that then again result in better graphics through higher polish? And another thing that is really interesting for me is indie games. Like a lot of indie games navigate this space much more consciously, and that's no doubt in large part because they can't afford to do AAA graphics in all cases. But there is this entire field of low fidelity games that I find like truly fascinating. And I don't think that, the next Call of Duty should look like that guy there. But that was, that Art of Faith was a talk at the last GDC. And I found it super interesting because this guy was describing how he didn't want to bother too much about graphics because he's an indie guy. But he also like consciously chose this rotoscoped line art style because he was making a horror game. And he very correctly thought that coupling this very high fidelity animation of the silhouette with almost no graphics would result in something very scary and unsettling and weird. So it was a very conscious decision to navigate that space. It's I think one of the best presentations that I've seen the year. And then again, I'm not saying that you should play only 8-bit games or things like that. This is Uncharted 4, like I just found out yesterday that they shipped all kind of bonus modes so that you can play it in this pixelated 8-bit mode and in a lot of others. So, and I'm not saying that rendering is not becoming less important or should abdicate its duties. It's the contrary, right? Asking those questions and making those conscious choices is the role of engineering, is the role of rendering. Okay? I just not pursue there is one single way forward. Those are all trade-offs, design axes, and then again, engineering is about navigating trade-offs. And I think it starts with asking those questions. Okay, so this is another example, another design axis that I find, then again, interesting, and I don't have answers about like where to land on this axis. And it is about generality versus specialization in our runtimes, in our engines. So I put here 2 examples. I don't know if you recognize the games. Maybe this is a little bit harder. So one is Destiny 2, and the other one is Call of Duty Infinite Warfare. And I chose them because I kind of know about both of them, even if I wasn't on the production of those games. But I was at Activision at that period of time. And also because they're both like kind of sci-fi space games. So they kind of look similar, but no, not really, but in the screenshots they kind of do. And then again, it's probably not the best examples And I'll probably make this story a little bit fictionalized, so it's partially fake news, but they're just scapegoats to explain what I mean by this design axis. So I'd say that Destiny rendering system skews towards generality. What I mean is that technical artists can do whatever they want. There aren't overly strong semantics. You have your mesh, your material, your decals. Materials are made with shader graphs. So you have those generic things, and you take a mesh, you put a material, and now it renders, right? And there are a couple of talks that show some of the behind the scenes of the Destiny pipeline. On the contrary, the original idea with Call of Duty, with the Infinity Ward, is to be very, very specialized. So you not only have specific type of objects with very specific rendering features that they can use, right? You have a system to create, I don't know, walls, and those will use tiled textures, and they can support only this number of channels and this kind of techniques, and they're kind of linked to how visibility is done. So there is specialization, and that specialization flows through the entire end-to-end pipeline. So maybe you have a kind of object that does its own specialized ways of editing it. It has its own rendering techniques. And then on the runtime, there is a very specific representation and a for loop that renders things very, very fast. So on one hand, we have this generality, flexibility, and this ability of more easily prototype and experiment. On this other hand, we have specialization, which brings you more performance and the ability of scaling, both like the runtime scaling, but also when I mean scaling is if you do things right, is also in production, because now you have these specific tools and you can make 1 million of this kind of thing, and you optimize that pipeline so you can make it very well. And yeah, like I don't know where we land. Like I don't see people explaining or talking too much about okay why we took this decision versus this other. And I mean, I can see both things having different set of constraints, because unfortunately, when I see a specialization, that end of things seems to be a little bit more rigid and constrained, but we have to also consider that we are limited by runtime. So if the things allows me to scale more, right, do a very specific thing, but do it much more, then that kind of thing is a constraint that I'm lifting. And now my artists can learn very well that path, and they don't have to think about runtime kind of constraints as strongly. So they're both ways that can be interesting. And moreover, constraints are not always negative, very, very far from it. And there are a lot of even scientific research or even just articles saying, oh, constraints help creativity. And this is not in the kind of survivor, or I don't know if you saw like primitive technology on YouTube, right? That kind of idea that lack of resources is stimulating your ingenuity. But in the much more complex issue that too much freedom and choice actually can impact our ability to work, to act, to make creative decisions. And yeah, I was mentioning performance is in itself a design axis, right? And a thing that we very rarely discuss is how much performance we are willingly wanting to sacrifice for kind of higher productivity. This is a video from a guy that try to hack games to bring them to the lowest setting possible, like outside of the realm of the slider. So you probably then again won't recognize this is Half-Life 2, pushed to the very minimum. Anyway, what I mean willingly is just not because we don't have time or the skills to optimize things, or because pushing for more performance would lead to like truly crazy and impractical solutions. But I've never like hear people saying, okay, we used to do this, but in this version of the engine, we evaluated that it's better to lose 5% of runtime performance and remove this kind of technical detail and yield higher iteration times or simplify things for our artists. Right? That is something that we never, or very, very seldom talk about. It's always like, oh, well, I did this and I saved 0.01 milliseconds, and it was like totally cool. One of the few people that I'm aware of who talks openly about this trade-off is Tim Sweeney. And this is a very old talk of his about programming languages for video games. And he has this thing: we'll gladly sacrifice 10% of our performance for 10% higher productivity. And I recently, had this reply. Like, so I was had this completely unsubstantiated, that's too hard to pronounce, theory of how Unreal and the other engines like dominated certain eras. And Tim was nice enough to reply to that and say, one can simplify in saying that the appropriateness of the trade-offs between runtime performance and developer productivity have determined the outcome of every engine war over every scale of project. So that was very interesting. And I think that the thing is, like, when it comes to our job, we kind of understand this. So we moved kind of quickly from writing things in assembly, right, to go to C, C++, or scripting language for fast iteration of animation and logic and stuff like that, right? And now we have maybe C# and visual scripting languages and other things. And we won't look back. And it's not that we won't look back because we are lazy and we like these very high-level things. It's because if we went back to assembly, it would result in making worse games that have worse performance, because we simply are at a level of complexity that we can't look at both things. We can't think of this very high level kind of algorithmic and whatever, experimenting with technology, while also micro-optimizing everything to assembly. Right? There is no question that compilers don't do as good a job as you if you were a skilled assembly programmer. People who say that the compilers, and they're wrong. Like, you can definitely outperform a compiler still, but you won't win because you will run out of time. And if you manage to ship the game, it will ship with whatever first guess you have at things, and in the end it will be a disaster. Right? So we don't look back into, oh, we should do more assembly. Because we know that our attention should be dedicated to this end of the spectrum. And this is, then again, it's a very general idea, even in how we are humans. We are constrained not only by time and money to make games, which are a big constraint, but even just the kind of amount of control and amount of things that we can fit in our head and reason about, okay? So, this is, of course, image of the original EA team and the EA Vancouver campus today. It's a large company. So the question is, as team size exploded, should have been moved our attention from code to the rest of production and do this similar kind of trend to a higher level of abstraction. And I don't know, did we really look at, are we now producing things with the optimal kind of balance between looking at high-level things and not caring about micro-optimization when we ask our artists to make UV maps and merge objects or split them or use different rendering systems? And I don't know, maybe we are, maybe we're not. I mean, to me, it's said that we're still largely working with the concept from early 3D games, right? We have triangle mesh, we have UV maps done by hand, some form of pre-computed GI, some LODs. Now, like, maybe, I don't know, many games do LODs automatically because of this, right? Like, not because we can make automatic LODs better than artists can, but because we simply don't have the time to ask artists to make high-quality LODs, and it ends up that automatic methods result in overall better quality and better performance, right? But other than that, we're pretty much using the same kind of primitives. Okay, yes, we did move to PBR, and that was arguably motivated by some of these production ideas. I don't know if we kind of lost our initial objective over the years. And we sort of moved towards photogrammetry. So that's another way of going a little bit more high level. But then again, I don't know if we are really nailing the right balance. And mind you, I mean it with I don't know, because it's open problem, so I don't know. But it's interesting to think about those things. And also, one thing that it is interesting to me is this idea of pushing more directly acquired data into runtime without a lot of hand optimization is actually now championed by animation. Or for a while, it was just like, oh, the animation is trailing behind rendering, and we should pay more attention to those things. And a lot of people did. So now many companies can kind of directly go from motion capture to using that motion capture in game, and they have like automated ways of cleaning up the motion capture, and nobody, well, no, that's not true, not nobody, but many games don't use people to hand annotate clips and branch windows and make motion trees and logic, right? So I don't know, like those are a couple of things that maybe are appropriate or maybe not. There was this idea of mega meshes, rendering directly from unstructured, like polygon soups. I love this idea of kit bashing that exists in some productions, and it comes from physical making models. And there are even crazier ideas, right? That's a screenshot from Dreams, going all SDF, and yeah. So then again, I don't know, but I think it's interesting to think about those things. And okay, so there are lots of other, I guess, axes that are interesting to think about when we start bringing in this human element into our techniques, right? Not making them just because they're shinier or because we can measure that, okay, we are reducing the error, but because we believe that they are on the right balance point between low and high level, and they serve some of our clients in some way. One, I guess, last thing that I think it would be interesting to think about, and I think that will be very important in the future, related to this embracing the human factors in computer graphics, is that, okay, we are today at a point that we sort of understand rendering and physics. Not really, but we do a pretty good job at rendering shiny metal balls. But we understand and think about remarkably, like, we understand remarkably little about kind of the people side of the equation, like the people receiving those images, so perception and psychology. And not because there isn't a lot of actual science about those things. Those are just like a bunch of examples, but there is a ton of science about those things. I think that, I don't know, a fundamental trick that would enable us to scale further is really to understand what matters in our frames and what matters from what we should really pay close attention to, and what we can cheat. And what we should even cheat, because we have lots of restriction in, you know, our output devices, our input devices. So it's not necessarily true. It's actually completely not true that if you just do your, you know, you solve your rendering equation numerically in the exact way, you get an image that it's perceived as realistic. And we kind of know about this when we think about tone mapping, right? That output thing is already something that we kind of understand, that there is an eye and a physiology and some whatever actual neural networks, right? But other than tone mapping, we really don't talk a lot about what we can cheat and what we could by finding how our brain perceived things actually hack to even look better, or to elicit certain sensations, certain emotions. And this is an aside. To be honest, I was never very bullish on VR thing. But I tried the Valve VR demo room in its early days in their offices, like in Seattle, and it was incredibly cool. So in that, like, I immediately wrote a little article about that after trying it. And one thing that I immediately noticed is how VR managed to cheat your perception, to shortcut your brain. So I could be in a room that was almost not shaded, like, clearly not high-end rendering, but because of the VR trickery and the presence and everything, like, tuned very well in that room and that environment with that hardware, my brain would still tell me, yeah, that's real. It's just very weird. And when you experience that, you're like, okay, then, like, it's interesting. I wonder how many other ways we can find to cheat our brain. Yeah. Okay, conclusions. I don't want to, like, drive this too long. So we want to do a lot more. And I think to do a lot more, we have to get better at understanding what and why. And we have to talk more about it. And then again, I'll say it yet another time, this is not like sociology or psychology. It is about technology. If we, the set of constraints that come with considering people in our technology make things much harder. And there is a lot of tech and R&D that we would need to do if we were to change any of those trade-offs and design axes. And then again, that's a fantastic talk by Alex Evans at SIGGRAPH a bunch of years ago, I think 2014, 15, about all the experiments that they did for dreams. And okay, now if you have this constraint that you want everybody to just take things and put them together and they render, right? How would you do that? And there is a lot of very exciting technology behind that, a lot of like cycle optimization of the PS4 GPU. Apparently, Dreams drives, I don't know if it's true, but I read rumors that it makes PS4s overheat, and that's like, oh, well, that has to be a very tight, optimized, 100% utilization render loop that you have there. So, okay, we don't really know people, right? Once we inject people thinking into this rendering equation, we don't really know what good rendering is. And then again, we should talk about more of these design trade-offs that we're making. And I feel that most of the choices that we landed on today are not made with a kind of inquisitive scientific mind. They are incidental around how teams evolved and how technology evolved, and some people made some choices. In fact, if you read the second part of that Tim Sweeney tweet, he says, no engine has ever fundamentally pivoted on this trade-off. So once you start it, kind of, that's what you get, and you start forming teams around those workflows, and we don't really change them. And by the way, you probably know this, like Sutherland's Sketchpad demo. It's incredibly cool. So as I was mentioning, I was in Montreal like last week, and there was this keynote by Andy Van Damme, which was fantastic, and he said that he would make the slides available, so you can check it out. And he was speaking about how much early computer graphics was actually about human-computer interaction. And specifically, if you look at the title he made of this keynote, how many of these pioneering ideas are still today not fully implemented, right? So we actually had a history of computer graphic caring a lot about human-computer interaction, and then we kind of forgot about it, or didn't realize its full potential. I think this is a duplicated slide. Okay, and it's also interesting because I feel that a lot of this R&D needs to be done by the industry, because we have the data about how we do production, things like that, and unfortunately this is data that it's even very hard to share. If you are in a game team and you want to say, oh, I want to publish our meshes so other people can investigate how we do stuff, the legal guys won't be very happy. And moreover, even like other than the data, we have the people, right? We have the workflows, we know the users, and lots of those problems don't have quantitative quality metrics. So if you go to your academic, like far out 5 years, to publish, you have to demonstrate that in some axis that it's numerically measurable. I don't know, this LOD is better than this other LODs. And a lot of those problems don't have those metrics. It's like, no, well, artists like it more, it's more natural. It's very hard to like express a lot of those things. And because they deal with people and humans, right? They tend to be harder. And yeah, then again, we know the users, people are tricky. There is also this thing that there are real costs to change. And this is another thing that I always struggled with, right? Because we go very fast in a way when it comes to the end rendering and runtime. And most other artistic fields don't work that way. Like it takes years or decades to really truly master a tool. But we kind of ask our artists to like, oh, well, and now lights are this way, and because I found this nice question in this book, and I want you to use this, right? And sometimes it's completely appropriate, and people naturally resist change. I won't say the company, but was this story of, in the transition to PBR, of artists really wanting one of the sliders that was going to go away with the transition to the physically based models. And apparently that slider was hooked to nothing, but they still really wanted it, right? So we naturally resist change, right? It's a human thing. But a lot of time we have also good reason, like that familiarity is an important thing, right? So I think that a lot of things, a lot of R&D either has to happen in a very incremental way, be mindful of not disrupting that work from familiarity, or we have really to be persuaded that it's so revolutionary that it's worth paying that cost, but that cost is still something that we have to be mindful of. And lastly, I think that we need to look at things more holistically. So we are really good right now at finding, I don't know, a better approximation for Fresnel. We are not good at saying, okay, this thing end-to-end to the image, what is the impact in perceptual kind of metrics? So I feel like that we're piling a lot of approximations. We have a lot of interest in more refined math and shaving milliseconds, but a lot of things is not really scientific in a way that we can really prove, yeah, no, well, spending 6 months on this thing was totally worth it because... and then again, we also have to think outside just, even if we did that perceptual end-to-end thing, that I don't think we do, we have to think outside just looking at the final image quality. We have to think about the time to quality, right? How much iteration we lose. That's pretty much it. That's what I did in the last 2 days. If anybody has questions they want to ask live, otherwise we'll just mingle and keep this going for a bit. No? Okay, cool.